Hello, everyone. Today we're going to do corresponding parts are in proportion. So, corresponding sides of similar triangles are in proportion. Therefore, if triangles are similar, then the corresponding sides are proportional. So, we're going to start off with a proof here to see how we can use that. So, we know that triangle ABC is isosceles with AB congruent to AC. And we know AF is an altitude to BC, which means that forms a right angle there. And PD is perpendicular to AB. So that's a right angle. So now we want to prove that FC to DB and AC to PB. So hopefully you can see here that I really have two triangles that I'm trying to prove similar. I'm trying to prove that PDB is similar to triangle ACF. And I saw that triangle based on the parts that I want to get in proportion. So let's see, how can we do that? So I'm going to erase what I wrote, and I'm going to go back to just my givens, knowing that I want to prove those triangles. So I just labeled those as right angles. So I need to say they're right angles. So angle PDB is right, and that's because of the definition of perpendicular. And then I know that angle AFC is right, and that's definition of an altitude. So I already have one angle in each triangle congruent. So PDB is congruent to AFC. All right angles are congruent. Now I need another one. Well, I knew that I was told that AB is congruent to AC because that triangle is isosceles. So that means that angle B is congruent to angle ACF. Because in a triangle, angles opposite congruent sides are congruent. So now I have those triangles are similar by AA. AA similarity. And then I can state my proportion, which is FC to DB is equal to AC times PB, because in similar triangles, corresponding sides are proportional. That's the end of the proof. So here's another proof, similar, and then I want to again write the proportion. Here they asked us for a part A, which is to prove two triangles are similar. So I should pause and try this proof and then come back and check it. Okay, so I started off by saying CED is congruent to BEF because vertical angles are congruent. I then stated that DC is parallel to AB because opposite sides of a parallelogram are parallel, and therefore DC is parallel to AF because extensions of parallel lines are parallel. You could skip that step. Then, since those two lines are parallel, I have this transversal DF. So angle EFB is congruent to angle CDE because parallel lines, alternate interior angles are congruent. Therefore, I have my triangles by AA, and then I have my proportion because similar triangles imply its corresponding sides are proportional. Okay, so now our last question is, given AB is parallel to CD, find the value of x in simplest radical form. So this is review. If those two lines are parallel, that means that these angles are congruent and these angles are congruent. So triangle FAB is similar to triangle FCD. So that means FA to FC is equal to AB to CD. We cannot use the side splitter because it's not, A, B, and CD are not the side being split. So I do my proportion, so it's x minus 1 over x minus 1 plus 2, because that's FC. I have to add those together, equals 4 over x plus 3. I simplify, so it's x minus 1 over x plus 1 equals 4 over x plus 3. Cross multiply, x minus 1 times x plus 3 equals 4 times x plus 1, x squared plus 2x minus 3 equals 4x plus 4. Make it equal 0, so it's x squared minus 2x minus 7 equals 0. That's not factorable, so I use quadratic formula. X equals negative b plus or minus square root b squared minus 4ac over 2a. Wants my answer in simplest radical form. So that's x equals 2 plus or minus square root negative 2 squared minus 4 times 1 times negative 7 over 2. I do what's under the radical, so it's x equals 2 plus or minus 4 plus 28 is 32 over 2. 32 has a perfect square factor of 16. So that's x equals 2 plus or minus square root is 16, square root of 2 over 2. 2 plus or minus 4 radical 2 over 2. Everything in the numerator can be divided by 2, so it's 1 plus or minus 2 radical 2. So that's the end of our video today. If you have any questions, please let me know.